Yeah, hi everyone. So we will wait for another 2 minutes. So let everyone join, then we will begin off with the session. So let's wait for another 2 minutes. Okay. So hello everyone, and if I'm audible to everyone, just write yes in the chat box, and we are good to go now. We'll start off with the session. It's already 7:03. So let's get started with the session. Just write yes in the chat box if you can hear me. Great, great guys. So let's get started with the session, right? So welcome everyone. Welcome to this webinar on working with NLP. And today we are going to talk about all about natural language processing. So I hope you guys are excited. So let's get started off with the session. And first of all, let's see what we are going to cover in this webinar. So here is the agenda. Here is what we are going to cover and we are going to talk about. First of all, we will talk about what is natural language processing, what exactly is NLP, and what are its application, what are the different applications of NLP. Then we will talk about the pre-processing the textual data. How do we do that? How do we process our textual data? And then we know that machine cannot accept data in its raw form, right? So we have to convert them in vector form. So we will learn how we represent words as vectors. Then we will talk about two methods, that is the bag of words and tf-idf, that stand for term frequency and inverse document frequency. So we are going to talk about all this, and also we are going to implement all these concepts. So whatever we learn, we are going to implement that. So we always believe in learning and implementing. All right, so it is going to be a hands-on session. So I hope you guys are ready with your systems so that you can work with me. All right, now let's get started. Let's talk about what is NLP, right? So before talking about NLP, these days if you see, then you have seen all these virtual assistants like Google, right? Google Home, and you have Siri, you have Alexa, right? Also Cortana, right? So these all are virtual assistants, right? So we human can understand the language, human language. So how does the how does this machine understand our language, right? So machine can only understand zeros and ones, that is binary digits. So how do they understand the human language and how do they reply us back? If you ever thought about that, so if you ever had thought about that, then you might have come to know about this NLP, that is natural language processing. So we are going to talk about that only. Now what is NLP? So NLP here, natural language processing, is a branch of AI. So NLP is a branch of artificial intelligence dealing with the interaction between humans and the computers using natural language, right? So here we talk with computers in our own language, right? You also give them instruction in your own language and they replies us back in our own language, not in bits, that is ones and zero. They talk, if you think about this, you will be fooled that someone is on the other side that is giving us the reply, some human, right? So we have come up with this NLP, that is natural language processing, and there has been a large advancement, right? People often confuse NLP with artificial intelligence and machine learning, and also your linguistic, right? So it is not your machine learning or artificial intelligence or deep learning. NLP is neither of that, but we use this concept to solve the NLP problems. So we use artificial intelligence, machine learning, deep learning. So these all are tools to solve our natural language processing problems, right? So people often confuse this with that it is a artificial intelligence or it is linguistic, but it is not so. NLP consists of systematic processes for analyzing, understanding and deriving information from the text data. So remember, here we are talking about the text data only. So NLP consists of systematic process where we analyze and understand the text data in a smart and efficient manner, right? So this is the definition that you will come across for NLP. All right, now let's talk about its application, right? So we know what NLP is. We are not going to do anything with this definition, right? All things that matter is that is the application. Where do we use it, right? So in recent past there has been a boom in this application of NLP. Almost every industry, if you talk about, is using NLP these days, be it your media houses, right, journalism, right, research, then all those different industries are making use of natural language processing, even in your education system, right? So these days it has boomed, and if you are thinking about making a career in NLP, then this is the right time. Dive deep into it. All right, so let's talk about some of the application. So I hope most of you have come across this Google search engine, right? We have this all search engines where we are making use of NLP. So it suggests you, right, whatever keyword you give on this Google, you type on your browser, then you are going to get some result, right? So how does it gives you most accurate result, right? So if I type the keyword Python on Google, then it is going to recommend me or suggest me the articles or the tutorials that are there based on this Python, right? Most appropriate. So here we are making use of nothing but your natural language processing. So sorry for that. So this is the one of the biggest application of NLP. Next, you might have used this translation from one language to another language or machine translation. So here again we are making use of NLP only. So here if you have your document in one language, that is, let's say in your mother tongue, and if you want to convert it into English, right? So if you might have come across Google Translation, Google Translate, or any other translation app. So here also we are making use of natural language processing. And also if you see, these days the products that are there on your e-commerce websites, right, or even the text data that is vastly present on Twitter, right? So you can analyze the sentiment out of this reviews or the tweet, sorry. So you can find the sentiment of the user. Let's say if you have launched a product, some product, let's say you have launched a shoes, and if you want to know how the people are liking it or whether they are not liking it, what is the sentiment in the customer, right? And what is the mostly they talked about your product. If they are talking positive, what is it that they mostly like? And if they are talking negative, right, what is it they doesn't like? What is the feature they want to add, right? So you can use this NLP there as well to get the sentiment of your customer, right? So here we are making use of nothing but your natural language processing. Again, during the election times, you see lots of tweets, right, regarding a particular party or some other political parties. So they also make I'm sorry for that. So also they are making use of this NLP only, right? So you see so much of survey before any election, right? So here they are using this sentiment analysis. Again, if you go to any website these days, you see a chat box pops up, right? It automatically pops up and then they describe whatever information that you need, right? So automatically they show you a chat box. Hey, whatever be your name, hey Manvendra, this is our task, right? This is what we do. Would you like to have any information, right? How do they do that? Have you think about this? How do they do this, right? How do they are able to fetch the exact information that you type there, right? Let's say if you want to know, if you go to some website and you want to know about something, let's say I want to know about machine learning. So there is a website that provides course on machine learning, and I go to that website, right? First thing I see is this chat box, right? Chatbot. So here what I do is, I should get the information. What I do, I want to know from when they are starting their next batch. So I type this question in the chat box, right? And automatically they fetch the information and gives you the information. Now how does this magic happen? So in behind of all this application is your natural language processing, and this is becoming a boom. This is becoming a boom these days. Next task, if you see, you might have used, everyone might have used this autocorrect, right? So you might have used this autocorrect in your phones, in your keypad, right? So you, whenever there is some spelling mistake, it tries to automatically correct that. So we are making here again, we are making use of NLP, that is your natural language processing. And also you might have seen that if you use Gmail, whenever you write a mail, right, whenever you go to write a mail, you might have come across that they automatically suggest you autocomplete, right? They automatically suggest you autocomplete. So if you write, I am applying for this, then you see that they automatically, you see that there is some text, right? There is some text to complete your word. There is some text to complete your word automatically. In Gmail, you might have seen that. So there again, we are making use of NLP, right? And also there are many more examples. This is not just it, right? You might have come across that there are different documents, right? There are different documents and we want to segment them. There as well you can use the application of natural language processing. And also, let's say you have bunch of keywords, right? Bunch of keywords, and you want to find the information regarding that keywords. So we call this as named entity recognition, right? There as well we are making use of natural language processing. So there are many more application of NLP in your virtual assistants as well. So whenever you give a voice command that is converted into your textual form first, then the machine interprets whatever you have said, and then you get the reply. So these are the application, some of the application of natural language processing, right? And the application of this NLP is increasing day by day in all the industries. So it is a booming technology. It is the right time to dive deep into this NLP. If you are thinking of making a career out of this, if it excites you, then definitely I recommend you to take this natural language processing as your expertise and specialize in that. Now let's move forward. So here we are working with mostly with textual data, right? So we human make so much of error when typing or writing something, right? We make so much of error. Right? If you see your tweets these days, you use your smiley, then there are some abbreviation, right? Social media abbreviation like LOL, RT, that is for retweet, and these all, right? So the textual data are full of ambiguities, right? Textual data are very much unstructured data. This is very much unstructured data. Textual data has ambiguities. We have to process them. We have to pre-process them. If you talk about this tweet only, right? If you have written any document, you might have seen yourself that you make so much of error, whether it is spelling error or some, we also use sarcasm, right? So how machine is able to detect all those sarcasm? We use in place of single comma, you might have used double commas, right? Might use punctuations, and there are different stop words that we use, right? How do machine interprets that? How it process that? So we have to pre-process our textual data because it is full of ambiguities. So we have to pre-process them. Let's consider this tweet over here. So we have this tweet from the user 123 @ user 123, and the tweet is I'm really happy. Then we have some exclamation mark, then there are some smileys, right? Then we have comma, then it has follow me, then you have this URL, right? And then then some dot 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 comma comma comma, right? So there are so much of ambiguity in this tweet, if you see here, right? So how do we pre-process them? So first of all, here if you see, there is Twitter handle, right? We don't want this information, that is @ user 123 and all those special characters and usernames. So we have this Twitter handle. We have emojis, right? So they might be useful to represent the emotion, right? So we can make use of these emojis to represent emotion. So we might remove and we might not remove. So all depends on your task that you are carrying out. Then here if you see, we have this URLs. We have this URL. So we don't require the URLs. So we have to remove the URLs as well. Then we have some stop words, right? So if you use all the stop words, I am this in the, right? So these are going to be present in huge amount, right? These are going to be present in huge amount, and if you use all these stop words, then it is going to make our corpus that we call all the data, right? It is going to make our data so big that it will take time to pre-process them, right? So we have to take care of them, that is stop words and punctuations. All right, So we have seen that there are some challenges with this textual data. So with text, these are very unstructured data. There are some ambiguities. So we have to pre-process them. Now, how do we pre-process them? I'm really sorry. All right. So in pre-processing, we have this first task, that is of tokenization. Now, what is tokenization? So tokenization breaks the raw text into words or sentences, right? So it breaks the words into single, it breaks the words into, it breaks the raw text into words and sentences, and we call this as tokens, right? So here we have this tweet at the rate user, I am really happy, and all these emotions, smileys and punctuations and stop words. So whenever you perform this tokenization, what we have done is we have this word, separate words. Now we have separated them. So we have at the rate, we have user underscore 123, then this is your colon, right? So we have tokenized them, we have made them as a token, all of these characters that are there in your tweet. So after tokenization, what we can do is we remove the stop word. After tokenization, we remove the stop words from our corpus. We call this as corpus. All the data set that we have, we call this as corpus. So please don't get confused with the word. Corpus is nothing but your all the data, right? So here we have this data. After tokenization, we have this data, that is, oh man, comma, this is pretty cool, full stop, we will do more such things, full stop, right? So this is our tokenized word, tokenized data. Now after removing these stop words, after removing your stop words, you have oh man, comma, you have removed this, right? We have removed is, because these are your stop words. These are nothing but your stop words that are going to make your data set even bigger. So we have to remove them, otherwise it will take time to pre-process them and build our model on them, right? So here we have removed all these stop words. This is, right? Then we have removed to, right? We have removed more, we have removed such. So after removing these stop words, we have oh man, comma, pretty cool, dot, we things, right? So we are able to preserve some of the information or some of the important words that are there in our data set, right? And we have removed the repeating words that are going to make our data set bigger. All right, now let's move forward. And after you have removed your stop words, we go for stemming and lemmatization. Now why do we use this stemming and lemmatization? So if you have a word, this might be present, your word might be present in different forms, right? Past, present, future, you have different forms of a single word. So here if you see this word was, also you can use it as be, right? Studies, studying, study, right? So there are different, there are different forms of a particular word. So we are going to convert them into their base form. That's why we use the stemming and lemmatization. So here if you see, well, how does this lemmatization and how does this stemming work, and what is the difference between them? All right, so we are going to talk about that. So here we have this word was, right? We have this word was. So if you do lemmatization, it is going to be converted into its base form be. We have converted this into be. But if you do the stemming, so it removes the characters, it removes the character from the end, that is s, ies, ing. So it removes all those words. So this is the difference between your lemmatization and stemming. So here if you see your studies, if you do lemmatization, it gives you study. right? If you do stemming, you have study, S-T-U-D-I. And similarly, if you do you see this word studying, it has been lemmatized to study, right, to its base form. But when you go for stemming, here you see that again it has been converted to its base form because we have removed ing. So sometimes this stemming might work and sometimes you won't get any information or any meaning from this stemmed word, right? So this is the difference between your stemming and lemmatization. All right, now after you have done this lemmatization or stemming, then we have pre-processed our words, right? So also there are different techniques to pre-process. Like if you want to, if you know that there is URL present in your data set, then you might use the regular expression, that is regex, right? So we will talk about regex when we move to our practical part. So it is most important to know regex. So if you don't know that, so it is not going to take more than 1 or 2 days to study and master regex. So I recommend you to study about regex and you will be fine within 2 days. You will be able to use the patterns. So you can identify the patterns from your textual data, right? So for that we use this regex functions. All right. Now after we have done all this pre-processing tasks, right? After we have done all this pre-processing tasks, next comes to represent these words in the vector form, or you can say in numeric form, because all the machine learning algorithms that are there, mostly they are going to work on numeric values only. So we cannot go and supply the raw text to any machine learning model that we want to build, because machine learning models or algorithms that are there they all perform some mathematical calculation, and mathematical calculation is not possible on your textual data. So you have to represent them into numeric form, or we call this as vector form. Yes, regex, so it is a regular expression. Let's say you have a word, right, and if you want to find out all the URLs, so you can make use of regex, that is regular expression. You can write a regular expression, so whenever you find that pattern, it is going to remove that and utilize that, right? So you just Google it, what is regex, and you will get it. All right, so it is pretty useful library or function, right? All right, so now let's see how do we represent them. So here let's say machine cannot understand the text in its raw forms, right? So we have to convert them into numeric forms. So consider the below reviews. Consider this review 1, review 2, or review 3 here. So we have the review 1 says this movie is very scary and long. Second review says this movie is not scary and is slow. And third review says this movie is spooky and good, right? So we have to vectorize the text. So whatever number of the reviews that we have to vectorize them. And there are certain rules that you must consider while vectorizing. So it should not result in a sparse matrix. We will talk about what is sparse matrix. And second rule is we should be able to retain most of linguistic information. So we should be able to retain most of the linguistic information from our text, whether we are representing this into vector form or your textual form, right? Then only the machine would be able to reply you back, right? No, regular expression is used to match any pattern or any pattern in your textual data, right? You can use it So here you represent them using bag of words. So we use this bag of words to build a vocabulary of all the words in the reviews. So our vocabulary, build a vocabulary of all the words in the reviews. So this is one method that we use to represent the text as in a vector form, right? So build a vocabulary of all the words in the reviews. So here let's say we have all these reviews, right? We have review 1, review 2 and review 3 here, right? So we have this movie is very scary and long, and review 2 is this movie is not scary and is slow, and the third review is this movie is spooky and good, right? So here we have to identify the unique word, right? So our vocabulary will be the unique words here. So here if you see, we have this unique word from all this review, from all these 3 review, you just have to obtain the unique words, right? So here we have this unique words. So the unique words are this movie is very scary and long, not slow, spooky and good. So we have identified the unique words from all these 3 review, right? After you have built a vocabulary of this unique words, then what you do is we have this review, right? We have this review and this is the unique words in your data set, that is in your corpus, that is your review 1, review 2 and review 3, right? So here what we are going to do is we are going to mark it as 1 whenever this review, whenever the word is present in that review, alright? So we have the this, alright? So we are taking for this review 1. So pay attention here, right? So where here we have this, alright? So this is this and it is present in this review 1. So we have marked it as 1. Then we have movie, right? So we have the movie, second word is movie, and here it is present in our review 1. So we have marked it as 1. Then the word is, the word is and it is present in our review, right? The word is and it is present in review 1. So we have marked it as 1 here. Then the fourth letter is very. The fourth word is very and it is present in our review 1. So we have marked it as 1. Similarly for scary and long, right? It is present in our review 1. So we have marked it as 1 and rest all we have marked it as 0. Rest all that is not present inside this review 1. In our review 1, the word that is not there, we have marked it as 0. Similarly, we do it for review 2, right? So here we have this review 2, right? It is this movie is not scary and is slow. So first we have to check for this. So this is present in review 2, right? So we have marked it as 1. Then the next word is movie, right? So movie is present in review 2, right? So we have marked it as 1. Then the third letter is, right? So is present in our review 2, and if you see, is present twice, once at here after movie and once here after end, right? So it has got the number 2, 1 plus 1, right? So here we have marked it as 2. Then very, right? So very is not present in our review 2. So we have marked it as 0. Similarly, we check all these words, right? So we have made a vocabulary of all the unique word, and then in different reviews or in different documents, we check for the presence of all those words and we take the count of them, how many times they are present. And finally, if you see, we have vector of review 1 represented as 1 1 1 1 and 0, right? Vector of review 2 represented as 1 1 2 0 0 1 1 0 1 0 0, right? Then vector of review 3 is represented as 1 1 1 0 0 0 1 0 0 1 1. Now if you have a big data set, right, if you have a big data set, then this corpus or this bag of words is going to get bigger, right? And you will have lots of, you are going to have lots of zeros. You are going to have lots of zeros in your this bag of words. So this is a problem. We call this as a sparse matrix. Whenever you have lot of zeros present in your matrix, then it is known as sparse matrix, and it is going to add a problem for us, right? So it is going to add problem for us because our data set will become, or our corpus will become so big that it will take time to build our model. All right, so here comes the, to rescue comes the tf-idf vectorizer. Now let's see how does this tf-idf vectorizer works. And also one thing, if you notice here, we are not able to preserve the semantic meaning of all these words, right? So if you give 1 1 and 0 zeros, if we represent in that manner, right, we are not able to get any semantic meaning, because this is also marked as 1, movie is also marked as 1, is also marked as 1, right? So all of them have the same meaning, same value, right? So we are not able to differentiate between them, right? So here comes to our rescue the tf-idf vectorizer. Now there are two terms in tf-idf vectorizer, that is term frequency and inverse document frequency, right? So let's see what is term frequency, tf, right? tf is equals to number of repetition of words in sentence by divided by number of words in sentence. So it will get clear, we will move when we move to this example. So just remember the formula, tf, that is term frequency, equals to number of repetition of words in particular sentence divided by total number of words in that sentence, right? And idf is equals to log. So we are taking a log here, log number of sentences divided by number of sentences containing that word, right? Just remember this formula. And tf-idf is equals to term frequency into inverse document frequency, right? Now let's talk about term frequency. So here if you see this first table, it represents our term frequency, right? So we have words, good, phone, laptop. So let's consider, after all the pre-processing, lemmatization and stemming and all those stuffs, we have got this corpus, right? So we have good, phone in our first sentence. In second sentence we have good, laptop, right? And in third sentence we have phone, laptop, good. So these are the three sentences after doing all the pre-processing tasks we have got, right? So here we have the words, the unique words that are there, that is good, phone, laptop, right? And these are our sentences, that is sentence 1, sentence 2, sentence 3. So now if you see the presence of good, so it is, we are calculating the term frequency. So we have the word good in sentence 1. So it says number of repetition of words in sentence. So we are looking at good. How many times good is present inside this sentence 1? One time, right? Is present one time. So 1 divided by total number of words in that sentence. So how many total number of words do we have in sentence 1? That is 2. So we have this 1 by 2, right? Similarly, for phone, the word phone, we calculate this 1 by 2 because it is present just once in this sentence 1, and the total number of words in that sentence is 2, right? So again it is 1 by 2 for phone as well. Then the laptop. So we don't have the word laptop in our sentence 1. That's why we have marked it as 0, right? And similarly, we calculate this for sentence 2 and sentence 3. So we calculate this for sentence 2 and sentence 3 as well. Alright, so this is our term frequency. We have built a term frequency. Now let's talk about inverse document frequency, right? So here we just have two columns, that is words, and we are calculating the IDF. So remember the formula, it is log of number of sentences divided by number of sentences containing that word. Alright, so here we want to find out the inverse document of letter good, of the word good. So number of sentences in our document, how many sentences do we have? We have 3 sentences, right? So log of 3 and good. So good is present in all these 3 sentences, right? Number of sentences containing that word. So all these sentences, 3 sentences, have the word or contain the good word, right? So it is given by 3 by 3. So log of 3 by 3 is 0, right? So log of 3 by 3 is nothing but 0. Alright, next we calculate the IDF for phone. Calculate the IDF for phone. So how many? So what is the number of sentences in our corpus? It is 3, right? It is 3. So 3 divided by number of times, number of sentences having the word phone. So only 2 sentences have the word phone, that is sentence 3 and sentence 1, right? So we have calculated the log of 3 by 2, which comes out to be 0.58. Similarly, for laptop, right? For laptop also we have log 3 by 2, which comes out to be 0.58. So this is your term frequency and inverse document frequency. Now what do? We multiply them. What do? We multiply them to get our tf-idf vectorizer. Alright, so here we have sentences. We have the sentences. Here we have sentence 1, sentence 2, sentence 3, and these are the unique words, that is good, phone and laptop, right? So here to calculate the term into inverse document frequency of the word good in sentence 1. So what is the TF value for good in sentence 1? It is 1 by 2, right? It is 1 by 2. So we have 1 by 2 into what is the IDF of good? It is 0, right? So 1 by 2 into 0 is nothing but 0. So we have got it as 0. Next, we calculate the tf-idf for the phone. So here we have the sentence 1, right? We are in sentence 1. What is the tf value for phone in sentence 1? It is 1 by 2, right? So we have 1 by 2 into what is the IDF value for phone? It is 0.58. So 1 by 2 into 0.58, it comes out to be 0.29, right? Then again for laptop, so for laptop it is not present in sentence 1, right? So the TF value is 0 and 0 into anything, it's 0. So we calculate the tf-idf vectorizer, right? Similarly, you do it for sentence 2, sentence 3, sentence n, right? So here if you see, we are able to conserve some of the semantic information, right? So the most common word, it is going to get a lower value. That is, if you see here, this good is present in all these three sentences, right? It is present inside all these three sentences. And if you calculate the tf-idf for good, you are going to get 0 only. You are going to get 0 only, right? And also, if you see the unique words, that is phone, laptop, right? They are going to have a high value. So we have conserved some of the semantic information, right? So this is your tf-idf vectorizer. Now we are going to move into Collab. We are going to implement it, right? We are going to implement this. So let's move to Google Collaboratory. I hope you have understood the theory. So let's head back to Google Collab, right? And here I'm going to write Collab. So if you haven't worked with Collab before, don't worry about that. Just go to your browser and write COLAB, that is Collab, and make sure that you are signed in your Google account. Make sure you are signed in your Google account, right? So click on the first link. Click on the first link here, Google Collab. All right, so it has opened. Alright, that's greater. So you might see this window. So you might not get all these options. So I have worked previously. That's why I'm able to get all this information, all these different notebooks, right? So I'm going to click on new notebook here. Click on new notebook. It will open a new Jupyter notebook where we can write and code, right? So let's open this. It is going to take some few seconds and you will see this screen. All right, so you will be able to see this screen. So here we have the title of our notebook. So let me name it as getting started with NLP. Getting started with NLP. All right, and here we have to connect to the runtime. So connect to the runtime. Here we can write the code, we can write text. So let me get some new code cells by clicking on code over here. All right, so we are going to build a model to predict whether SMS is a spam or ham, right? So whether it is spam or not. So we are going to build a model for spam classification, and we are going to make use of the space classification data set. You can find this data set on Google Collab, sorry, Kaggle. So just go to SMS spam data Kaggle. If you write this in your browser and just enter it, then here you are going to get this first link. Just click on this first link, right? So just click on the first link, and here, from here, you will be able to download this data set. So it is just of 491 KB. You can download it, right? And you can use this data set. All right, so make sure you are logged in your Kaggle account, otherwise you won't be able to download. Anyways, we are going to share this data set with you guys after the session. Don't worry about that. All right, so here we are going to make use of that data set. All right, so here first of all you have to import. So let me zoom in so that you all can see it. All right, so here first of all we have to import all the necessary packages. So import necessary packages. All right, so here we are going to import the necessary packages. So import pandas as pd, import numpy as np, import matplotlib, matplotlib.pyplot as plt, and import keyborn as sns, right? And also import NLTK. So we are going to make use of this NLTK, and also we are going to make use of regex. So import RE, that is regular expression, right? And also we are going to import string. So we are going to make use of all these libraries. We are going to make use of pandas to read and analyze our data, all right? We are going to make use of NumPy to do all the scientific computation. We are going to make use of matplotlib and cborn to plot our graphs. We are going to make use of NLTK for pre-processing. So these are all three packages that we have: NLTK, regular expression, and string. We are going to make use of them to pre-process our textual data. All right. Now let's read this data set first. So first task is to read this data set. So to read this data set, here let's first run this first cell. Here I'm going to write df. So we are going to assign this data set into df variable equals to pd dot read, pd dot read underscore csv, right? pd dot read underscore csv, because our data set is in csv format, all right? So pd dot read underscore csv, then we have to give the path. We have to give the path of our data set, right? So here I'm going to click on this folder icon over here, because I have my data set in my drive. So I have my data set in my drive, and from drive I'm going to use this directly. So click on this folder icon, file icon here, then you will see this window, you will see this option. So here you have to click on this drive, that is mount drive, this icon here, mount drive. So click on this mount drive. You will get this pop-up which says connect to Google Drive, will permit code executed in this notebook to modify files in your Google Drive. So I'm going to click on connect to Google Drive over here. So just click on connect to Google Drive, and within some few seconds you will see another option of the drive here, right? So you can see the option of drive. So just click on this drive, then click on the my drive. Then here you will be able to see all those folders that are there in your Google Drive. So here I have stored this data set in my getting started with NLP folder. So I'm going to click there, and here you see that we have this spam.csv. We have this spam.csv. So I'm going to do a right click, and when you do a right click you are going to get all these options. So here I'm going to click on copy path. So just click on copy path and go here and paste the path, all right? And also you have to do the encoding. So this has been encoded in some other format. So for that we are going to give encoding. Encoding equals to, you have to give the same encoding ISO your 8888859 -1, right? So this is the encoding, and to let's run it. Let's just run this. All right, so we have read the data. We have read the data. Now next task is to check the head. So we want to have a top view of our data set, top view of our data, right? For that I can write df.head, and it will give back the first 5 values or first 5 rows of our data set. So let's just check that, right? So here we have this v1 feature that has the value ham and spam. So this is our target label that we want to predict. This is our target label that we want to predict, and this is the message. Based on all this message, we have to predict whether it is a ham or spam, whether it is spam or not. All right, and this unnamed 2, unnamed 3, unnamed 4, I think these are unwanted features, so we have to remove them. And to remove them, you just have to write, so here you just have to write df dot drop, df dot drop, and inside this braces you can give columns equals to, so we are going to pass this all features, that is unnamed 2. I'm going to copy it, I'm going to paste it over here, right? Then comma your next feature, that is unnamed 3. So these are just unwanted features, we have to remove them. And control V, again I'm going to copy the unnamed 4 column and I'm going to paste it over here. All right, and now we have to make these changes, we want to reflect the changes in our original data set. So for that I'm going to write in place equals to true, right? And let's just run this. So let's just run it, and now if you check your df dot head, you won't be able to see these 3 features anymore. So we just have the messages and their labels, that is ham or spam. Alright, so I hope it is clear to you. Let's move forward now. Right, so let's move forward now after we have dropped these columns, right? So let's move forward and let's just check the few of the information. So let's just check the few of the information here. So let's check the shape of the data set. So check the shape of the data set, that is how many rows do we have in this data set. So check the shape of data, and to do that you just have to write df dot shape. Df dot shape will give you the shape of this data set, right? Let's just run it, and here we have 5572 messages and we have their labels, right? So these are the number of rows in our data set, and these are the number of columns in our data set. All right, now let me get some new code cells. We're going to require more code cells. All right, so here let's have a look at, let's differentiate, let's count the number of ham messages that are there in our data set and number of spam messages in our data set. So one way you can do is df your v1 df v1, right? And here you pass right dot value underscore counts, and if you run it you'll get the count of ham and spam, right? So ham values, we have 48825, we have 4825, and the spam is only present for 747 values, right? So we have 747 values for spam messages for spam, and we have 4825 to identify the messages as ham. So we have lot of ham messages, right, and only few spam messages. So this data might be collected previously when we don't use this WhatsApp and all. These days if you check your phone, most of the messages are spam only, right? Most of the messages are spam only. There are very few messages or text that you get, right? Most of the time you prefer WhatsApp, right? So here we have very less value for the spam messages. So there is a class imbalance. So there is a class imbalance, and better way to visualize this would be SNS get a bar plot, SNS dot count plot, and here I want the count of this v1 feature. Now if I run it, here you'll get a nice graph representing the representing the ham and spam values, right? So how many, if you see this spam messages, there are very less, that is around 750, right? And most of the values we have it as ham, right? So we have very few spam messages in our data set. So there is a class imbalance. So we have to come up with some solution to handle this class imbalance. So we are not going to talk about that, as this webinar is completely based on the NLP task only. You can refer to other videos on our YouTube channels. So we have uploaded it, what is class imbalance and how to tackle them. All right. So now let's move forward, and now let's look at some of the ham and spam messages. Let's look at the sum of the ham and spam messages. So first of all, we have to differentiate them. So we have to differentiate this ham and spam messages, right? So here I'm going to write ham equals to tf dot log. So we are just looking for the ham messages, right? So it is v1, so df dot log tf, and your v1 is equals to your ham, right? Dot reset index, dot reset index. All right, and let's check the first 5 ham messages. All right, so let's check the first 5 ham messages. So here I'm going to write for I in range 5. For I in range 5, you want to print the first 5, right? So I'm going to write print ham your vi, that is v1, right, and I. So it is going to print the ham messages 1, 2 and 3. So let's have a look at them. So let's just run it. So I think we have made a mistake here, so let me correct it, right? So it should be df dot log, then we have df and v1 double equals to ham dot set index right. Now if I print my ham, all right, so here I'm going to write df dot log and dot reset index. All right, and now if I run it, you'll get the ham messages. All right, and okay, so we have got the index variable, so no problem with that. So just let's write a follow for I in range 5. For I in range 5, we want to print your ham of v2, right? It is in v2, and print the first 5. Let's just run it, right? So here we have this ham messages. So let's look at some of the ham messages and read about them, right? So let's talk about that. So here if you see, we have this ham messages. So these are not the spam messages, these are ham messages. So go until Zurong point, right? Crazy, available only in Bugis and Great World, Live Buffet, sign there some, got amor, what, right? So it seems like that someone is texting someone they know, right? And this is the second one, second ham message. Okay lad, joking with you only, right? So here this is also this looks like that they know each other, so they have been texting, right? And you have the third one, you don't say so early, or you see already then say. So this is also ham message, right? So it clearly signifies that the person, they know each other, that's why they are texting each other, right? Similarly, I'm going to copy this code and I'm going to paste it over here, and this time we are going to find this for spam, right? So let's look at the spam messages, some of the spam messages here. So here I'm going to make it as spam, and here as well it should be spam. All right, now let's just run it and see the some of the spam messages here. All right, so these are the spam that we regularly get in our cell phones, right? Now let's just read about this. So free entry in to a weekly comp to win FA Cup final tickets 21st May 2005. Text FA2 8787 and so on, right? Blah blah blah. All right. So this is our spam message, right? This is our spam message. Now, if you see this spam message, it clearly signifies that they are offering some free messages, free prizes, right? You have won something or you are working on something, right? So these all kind of information that is there, right? Six chances to win cash from 100 to 20,000. They have included some amount. They are providing this free cash, right? Then it says winner and all this information. You have this euro 900. So these all are the kind of spam messages. So we can definitely separate these two classes based on this text, right? So now let's look at that. How do we do that? So first of all, if you see here, the spam messages a bit longer. Spam messages are a bit longer than your ham messages, right? So your spam messages here, if you see, these are a bit longer than your spam messages. Sorry, ham messages. So what one feature we can make out of this is the count of words in spam and ham messages, right? So let's do that, and to do that I'm going to write tf your new feature. I'm going to add word underscore length in our df, and it is going to take this df your v2 dot apply the length. You want to find the length, right? And this time if I print df dot head and just run it, let's just run it, right? So you have the word length over here, right? We have the word length. What is the number of words in that particular SMS, right? So this is the word length. Now let's check the mean of the words in ham and spam messages. Let's have a look at the mean words in ham and spam messages, right? And to do that I'm going to write df dot group by, and we are going to group by the v1, right? We are going to group it by v1, and we want to find the mean of the word length. So word underscore length dot mean, word length dot mean, and if you run it you will get the mean of, so we have done a spelling mistake I think here, so I'm going to copy it here and I'm going to paste it over here. Alright, so it should be, we have made it as one underscore length, no problem with that, just change that, right? So here if you see, ham messages has the mean of 71 words per message, right? So the mean is 71 words per message. But in spam, these are a bit longer, right? We are getting 138 words in that spam messages, right? So definitely we can add this as a feature in our programming, right? In our model. All right. Now let's move forward. And we are going to do some pre-processing now. We're going to do some pre-processing now. So here, if you see your text, right, you have all these top words, we have punctuations, we have different, we have to pre-process them. So we are going to write a function for that. We are going to write a function for that, right? And here, let's write the function to do the pre-processing. So let's just write the function. And first of all, before writing the function, we have to download some of the top words and also the punctuations, and also we have to download the stop words. All right. So here, to download the stop words, you have to write nltk dot download, and inside this braces we give stop words. Right, so nltk.download stop words, and next we are going to write from nltk dot stem, or from nltk dot stem import coordinate Lematizer, right? So from nltk.sem import wordnet lematizer to lematize, and here I'm going to create a instance of this lematizer. So lematizer equals to our wordnet lematizer, wordnet, it should be WORD, wordnet lematizer, right? This is the instance of this wordnet lematizer. All right, and stop words, stop underscore words equals to your nltk dot corpus dot stop words. So we are downloading the stop words. We have downloaded this stop words, and now we are storing this stop words in our, making a corpus of it, and we are storing this in variable stop words. So stop words dot words, and this stop word should be English. Stop word should be English. All right. Again, we have imported the string. We are going to download the word name. So nltk dot download the word name. Download word name. All right. Now let's just run this. It should be nltk right, so just make it nltk. I've given nlt. So yeah, it should be, yeah, I've given the underscore. It should not be the case. We should not give underscore. All right. So we have imported this. We have downloaded the wordnet stop words, right? We have made an instance of wordnet lematizer for lematizing. Now let's write this function. Right, so we are going to write a function. So here I'm going to write a comment. So function for pre-processing our data. All right, and here I'm going to write def. So I'm going to name it as preprocess underscore text, preprocess text, and it is going to take this argument text. And here I'm going to define what does this function do, right? So we are writing a function we are writing a function to do text pre-processing. Text pre-processing. So we are doing a writing a function to do a text pre-processing, and first thing we are going to do is convert all the words, convert the words into lowercase, convert the words in lowercase. This is the first task it is going to do, right? And then we are going to perform remove punctuation. We are going to remove the punctuations, right? And after we have removed the punctuation, the third task we are going to do is we are going to remove the stop words, all right? And after removing the stop words, we are going to tokenize the word. We are going to tokenize the word. All right. And the fifth task we are going to do with this function is lemmatization. We are going to lemmatize it. We are going to do lemmatization, right? We are using this triple quotes, so it is multi-line comments. It is used for multi-line comments. So here I'm going to write this text equals to, right? And here dot join, so all the words that we pass in, right? And dot join, and here word, I'm writing a list comprehension, word dot lower for word in text if word not in string dot punctuation, right? So if the word is not punctuation, then we are going to lowercase it, right? So we are going to lowercase it. All right. And next I'm writing tokens equals to re dot split. So we are making use of regular expression here. The first argument you have to give the pattern, which pattern it should split in, right? So we want to split with the empty spaces, white spaces, right? It could be any white spaces. So we want to remove the white spaces. We want to split all this, tokenize the data from the white spaces, all right? And here we are going to pass this text. All right. And here again text equals to we are going to lemmatize now. And here I'm going to write lemmatizer dot lemmatize, right? Lemmatizer dot lemmatize to lemmatize the word, right? So lemmatizer dot lemmatize word for, so it is again a list comprehension for word in tokens if word not in stop words. So if the words are not stop words, then only perform this lemmatization, right? And we are going to return all the text after doing all this pre-processing. So again we have to join them. So dot join, right? Otherwise you will get the list, right? So dot join your text. Let's just run this, and now we are going to, let's just check how does this pre-processing function work. So I'm going to write preprocess underscore text, that is our function, right? And here I'm going to pass df our v2 and the first value 0, right? And let's just see. So I think we have made some mistake. Let me cross check once. Let me check it one more time. So it is returning us some empty values. So it should not be the case. Let me check just once. Alright, so here it should be empty space. So again we are getting this empty space. We have done some mistake. Let me cross check just once. Alright, so I think space here. Let's just run it. We are not able to get this output. I don't know why, because everything is fine. So let me do it one more time. We have to pass this pre-processed text and df v2. It is in v2, right? Cross check once. It is in v2, and so just a second, guys. Cross check it. Let's check it one more time. All right, so let me do it one by one, so we will get the output. All right, so we are going to write, so I'm going to remove this all. We are going to take the text and we are going to write text equals to our, we are going to convert the words into lower form. So we are going to write text dot lower, right? Then what we are going to do is we are going to remove the punctuation, right? So punct equals to punct equals to, we are going to write word. So I'm going to write word for word in text if word not in string dot punctuation. All right, so if I write string dot punctuation, let me check that, string dot punctuation, and if I run it, we are getting all this punctuation, right? We want to remove all this punctuation. That's fine. All right, next I'm going to tokenize it, right? So we are going to tokenize it. So tokens equals to your re dot split with the empty spaces, so we don't have to give anything, re dot split, and here let's split it by empty spaces, comma, and here you have to pass the punct. All right, next what we are going to do is we are going to lematize it. So text equals to we're going to write lematizer dot lematize your word, right? Your word if for word in tokens if word not in stopwords. right? And what is our stop words? So if you just run this stop words over here, you'll be able to see all the stop words. Let's just run it, and here you'll see that we have all these stop words, right? So we have written lematizer.lematize word for words in tokens if words are not the stop words, right? And we are going to return empty space dot join your text. All right, now let's just run it, and now let's just run this function, that is preprocess text on our tf v2 and 0. Just a second, here again we have to do the same thing. We have to convert this, we have to join them. All right, so here I'm going to write this lower, and now let's just write dot join, right? So empty space dot join your func, this becomes your word, call this as func only, right? Text if word not in punctuation. Now let's run this. So is this token, so it should be tokens. All right, and now let's just run it. Should work now. So here we are getting all this. I haven't joined them, I think. Let me check, cross check it. Comment this and run it. Just a second. This is the problem sometimes with the, it should be your func. All right. So I don't know why we are getting this type of values. Let me write it one more time. So here I'm going to remove all this, and again let's just write it from basics, right? So here let's perform the first task, that is text equals to dot join your word dot lower for word in text. If word not in string dot punctuation. All right, now next what we want to do is we want the tokens. So tokens equals to re dot split, right? We are going to split it with backslash, that is w, and plus, so it should be capital, all right, comma text. All right, next we are going to write text equals to your lematizer dot lematize, right? Your word for word in word forwarding tokens, sorry, so word in tokens if word not in word not in stop words. All right, and it should return, this function should return us after joining all these values. So dot join your text. All right, now let's just run it. It should work fine now. All right, so this is our pre-processed text. This is our pre-processed text, right? So if you want to check the original text, here you can write df v2 and your 0. And here if you see, this is your original text. This is your original text. Here we have go until journey, Jurong point, right? Crazy, available. And here if you see, we have reduced the size, we have lowered the cases, we have removed the stop words, right? So we have done our pre-processing task. Next, we should represent them into vector form, then only we can apply any machine learning model, right? So here let's just write that. So here let's just do that here, right? So here I'm going to write, we are going to pre-process it. After pre-processing, what we have to do, we have to represent them in vector form, right? So here we are going to represent them into vector forms. First of all, we have to apply this pre-processing step on all the messages, right? So we are going to apply this in all the messages, right? So here I'm going to write df your v2 that has all the messages. This feature is storing all the messages, right? So df v2 equals to df v2 dot apply, and we are going to make use of this lambda function, lambda x, such that, and here you give the statement whatever you want to do. So we are going to apply the pre-processing, right? You want to pre-process it. So pre-process underscore text, right? And your x. And here if you see df dot head, you will see that your all the messages has been pre-processed. So we have the pre-processed messages. Now we have to represent them into vector form. So we have to convert this v1, right? This is our target label, into numeric form. So here to do that, I'm going to map this. So df v1 equals to df v1 dot map, and here I'm going to pass it as your ham is going to be converted into 0, mapped into 0, and spam is going to be mapped into 1, right? So this we have done. Now we have converted this to see df v1, right? So now if you check this df v1 will have 0, so sorry, this should be v1. Now you will have ones and zeros. Now we want to convert this text into vector form, and for that we are going to make use of bag of words using sklearn package, right? So here first of all you have to import the package from sklearn dot preprocessing dot text. From sklearn dot preprocessing dot text, import count vectorizer, right? And if you run it, you will import this count vectorizer. So I think we have made a spelling mistake. Let me check. All right, so let's check this. Okay, so this should not be pre-processing, it should be feature extractor. So from sklearn dot feature underscore extractor right? Import count vectorizer. All right, and we have imported this. So again we have made some mistake. FEH, we write it. So from sklearn dot feature extraction dot text import your count vectorizer. All right, your CV equals to create an instance of this count vectorizer, right? And here I'm going to pass this, analyzer equals to word, right? And here again what I'm going to do is I'm going to define df underscore 1 equals to CV dot fit, right? So we are going to apply this count vectorizer. CV dot fit transform CV dot fit transform your df and v2 feature, right? We have this transforming our feature into vector form, and let's just show this df dtm equals to pd dot data frame. So I want to show this into data frame format, right? pd dot data frame, and here I'm going to apply df underscore 1, so 2 under dot 2 array. So we are going to convert this into array, and your columns are going to be your columns equals to your cv dot get underscore feature. So whatever feature unique word that we get, feature underscore names. All right, now let's just print this. Df underscore dtm, and let's just run this. Right, so you see your text has been converted into a vector form, right? And here if you see, you have got 8,829 new columns. So your each word has become a feature here, each unique word, right? And if you see, we have lot of zeros here, right? So this is a sparse representation. All right, now we want to convert this into, we want to apply a machine learning model here, right? So our task is to classify the spam and ham messages, right? So here we are going to split them into training and testing part. So we have to split them into training and testing part. First of all, I'm going to store this x equals to our df underscore dtm, whatever vector we have formed just now, right? So we are going to use this messages, classify them in as spam and ham, y equals to your df v1. All right, next I'm going to import from sklearn dot model underscore selection import your train test split. All right, and here I'm going to write x underscore train comma y, sorry, it should be x underscore text comma y underscore train comma y underscore test, right, equals to your train test split, train underscore test underscore split, right? And here I'm going to apply x comma y comma your test size, test underscore size, we are going to give it as 0.25, and comma random state equals to, let's give it as 42, right? And let's check the shape of our training data. So let's check the print x underscore train dot shape comma y underscore train dot shape. and let's just run this, right? So we have 4179 values for training our model and rest for testing, right? So let's just build a name based classifier. We are going to build a name based classifier. So from sklearn dot name base import multinomial nb, and here we are going to write clf equals to your multinomial nb. So we have created a instance, and next we are going to fit this clf dot fit your x comma train comma y comma train, right? And also let's check the score of this model, right? So here we have to predict equals to clf dot predict your x test, right? And next your print the accuracy. So we are going to check the accuracy. So clf dot score, right? So it is going to give you the accuracy score, right? You write clf dot score your x train comma your y train. All right, now let's just run this model and see how accurate we are, right? So here if you see, we are getting 0.99 accuracy, but as we have a class imbalance in our data set, so this was case, right? It is most likely that we are going to see it. So let's build a confusion matrix. So from sklearn dot matrix import plot confusion matrix, all right? And here let's just plot underscore confusion matrix, right? And here it is, the model is clf and your x underscore train comma y underscore train, right, equals to, and then your value format is going to be in decimal. So value underscore format equals to t. Let's just run this. All right, so format value, I think format value format, yeah, I was right, value underscore format t. Run this, right? So you see our model is doing a nice job, right? So if you see, this is our true label, right? So it is 1, predicted true label is 1, and also we are able to correctly identify 540 values as true, right, as spam. So there are in our training data set. So it is working quite fine, right? It is working quite good, right? So another method that we can make use of is your tf-idf. So this is the bag of word method. Another method is tf-idf, right? So you don't have to do anything for that, and for that what you have to do is you just import. So again you just have to write one line of code. So you just have to write from sklearn dot feature extraction dot text import your tf-idf vectorizer, right? And the rest, all the steps are going to be the same, right? So here I'm going to copy all those. I'm going to copy all these steps and I will change the variable name only. I will copy all this and I will change the variable name, right? So I'm going to paste it over here, and this time I'm going to make it as, this should be your tf-idf vectorizer, all right? So let's just copy it, and here again just paste this, right? So just paste it over here, and rest all just keep the same. Let's just run this, right? So here again you have this values, all right? So this also going to give you a sparse matrix, but if you see, you will get some values. So you have high value for unique words. Cannot see it because our corpus is very large, right? And next all steps are going to be same. So I just copy this step, copy this code, and just paste it over here, the next line. So just paste it over here, and if you run it again, right, so this is for, we are doing it for tf-idf vectorizer. And again, let's just build this model. So you just have to import this tf-idf vectorizer, and rest all the steps are same, right? Let's just build our model and check the score. So here we are getting a 0.97 score, but this is nice because we are also getting a high value, right? So our model is working fine, and this might be able to also show the linguistic, that is context, right? So this is it for this webinar. I hope you guys enjoyed it and learned from it, right? So you'll get all the session, the files that we have been using, so it will be given to you. Don't worry about that. I hope you guys enjoyed the session, and if you have any doubt, go ahead, ask your doubts. So again, we are coming up with many such webinars on different topics, so you just stay tuned, right? You will learn many things, and that will be free, obviously. And you can also join us in our Facebook group and also on Instagram. There you will get the regular updates and also interesting questions for you to solve. Thank you very much, everyone. I hope you guys enjoyed the session.